In this video, we're going to try to figure out the one-dimensional flight time and the maximum height a projectile reaches when it's launched straight up into the air. So this is going to be the coordinate system that we're looking at, and we're going to consider a projectile that is launched straight up into the air. And we're going to give this projectile an initial velocity of 60 meters per second. Now we're going to assume that this projectile is massive enough that the effects of air resistance or drag are negligible on this. Now what's going to happen is this projectile, when it's launched straight up into the air, is going to start slowing down until it reaches a final velocity of 0 meters per second over this interval of time. Now one of the things that I hope you see is that this object has some velocity in the upward direction, and the force of gravity is going to be accelerating this object in the downward direction at negative 9.8 meters per second per second. And another concept that you should get is that when the velocity and the acceleration vectors point in opposite directions, this object's going to slow down. Now the first question that we're going to answer is how long this projectile is in the air for. So what we're going to do is we're going to use our kinematic equation that says that the final velocity equals the initial velocity of the object plus the acceleration times the time interval over which this object's slowing down. Now in this case, we know our final velocity is 0, so we can rewrite this expression as 0 equals the initial velocity plus the acceleration of the object times the time over which that object's slowing down. And then what we want to do is we want to move this initial velocity term over to the other side. So to do that, we're going to subtract the initial velocity from both sides. What you do to one side of an equation, you do to the other side. And then what you get is the minus initial velocity equals the acceleration of this object, which is the acceleration due to gravity, times the time interval over which this object is going to slow down. Now the last step is to divide both sides by the acceleration. In this case, it's the acceleration due to gravity. And this term should cancel out with this term. And we'll get an expression that says that the time that this object is in the air for, that is from when it goes from the point where it's launched to its maximum height, is going to be negative v initial divided by the object's acceleration. Now the initial velocity in this case is going to be 60 meters per second, so it's going to be minus 60 meters per second, and then we're going to divide that by the acceleration due to gravity, which in this case is negative 9.8 meters per second squared. Notice a negative divided by a negative is a positive number, and when we do 60 divided by 9.8, we get about 6.12. And in this case, a meter per second divided by a meter per second squared is going to work out to be a unit of a second. So this time represents the time it takes for this projectile to go from where it's launched to its maximum height. And so to figure out the time it takes to go from the launch point all the way up to the maximum height and then back down to the launch point is going to be 2 times the time it takes to go from the launch point all the way up to the maximum height. So in this case, this will work out to be 2 times 6.12 seconds, which should work out to be a total flight time of 12.24 seconds. So this is going to be the total time the projectile is in the air, and this is going to be the time it takes to go from the launch point all the way up to the maximum height. Now the last thing that we're going to do in this video is we're going to figure out the maximum height, that is the total distance in the upward direction that this projectile reaches. Now in this case, our delta y is going to be a positive number because the projectile is moving in the positive y direction. Now there's going to be 2 different ways that we can figure out the maximum height of this object. The first way is to use the time it takes to go from the launching point all the way up to the maximum height, which in this case was 6.12 seconds. This is not the total flight time. This is just the time it takes to go from the base to the very maximum point. And to use this time, we'd use the kinematic equation, which says that the change in height of this object equals the object's initial velocity times the time over which this object's in the air plus 1/2 the acceleration of this object, which is the acceleration due to gravity, times the square of the time that this object is in the air for. Now in this case, the object was launched with an initial velocity of plus 60 meters per second straight up into the air, and then we're going to multiply that by the time that this object's in the air for, which is 6.12 seconds, and then we're going to add 1/2 of negative 9.8 meters per second squared. This is how fast gravity is slowing down the projectile as it's moving in the upward direction, times the square of the time term. Now 60 meters per second times 6.12 seconds is going to work out to be 367.2, and what you should see is that this unit a second cancels out with this unit a second, and then you get a unit of a length or a distance, which in this case will be a unit of a meter, plus 1/2 of negative 9.8 meters per second squared times 6.12 seconds quantity squared, which will work out to be negative 183.5 meters. And what you should see is that when we square this term, we get a unit of a second squared, which will cancel out with this unit of a second squared to give us our unit of length, our unit of distance. So now to figure out the height, all we have to do is add these two numbers, 367.2 plus a negative 183.5, which will work out to be a positive 183.5 7 meters. And this is going to be the maximum height that this projectile reaches. Now there's one other way to figure out the maximum height, and that's to use our kinematic equation, which says that the final velocity squared equals the initial velocity of the object squared plus 2 times the acceleration times the change in height of this object. That is the maximum height this object reaches. Now in this case, the final velocity would be 0, so we'd get 0 equals our initial velocity squared plus 2 times the acceleration times the maximum height of this object. Now in this case, we're going to move this squared term over to the other side, so we're going to subtract v initial squared from both sides. What you do to one side of the equation, you do to the other. So you'll get negative v initial squared equals 2 times the acceleration due to gravity in this case, times the maximum height that this object reaches. Now in this case, what you're going to do is you're going to divide both sides by 2 times the acceleration, in this case the acceleration due to gravity. So what you do to one side, you do to the other. And what you should see, this 2a cancels out with this 2a, and you get an equation which says that the maximum height this object reaches equals minus v initial quantity squared divided by 2 times, in this case, the acceleration due to gravity, which will work out to be negative, our initial velocity was 60 meters per second, and we're going to square the entire term, divided by 2 times negative 9.8 meters per second squared, which will work out to be a positive 183.6 meters. And again, notice that this negative sign cancels out with this negative sign, and so we got the exact same value that we got using the other method. So what I'm hoping that you'll see is that there's more than one method to find the maximum height that an object reaches, depending on what information you actually know.